Hi everyone, in this video we're going to be looking at Pythagoras' theorem, which states that when we are finding the side lengths in a right angled triangle, the sum of the shorter sides, when we square them, equals to our hypotenuse squared. So it is stated that a squared plus b squared equals c squared. So the properties that we need to know are in a right angled triangle, which is a triangle that contains a 90-degree angle, that's called a right angled triangle. The side opposite that, so this side here, is what we call the hypotenuse. And the two main properties of a hypotenuse is that number one, it's the longest side in a right angled triangle, and two, it is always opposite the right angle. So using that, we're looking at substituting what we know to find the hypotenuse, or we can also work backwards, which we'll look at in a little bit. So let's look at a question together. So if we have a right angled triangle, let's say this is given as 3 meters, this is 4 meters. Our first step is always to label the sides. So looking at that, we do not know the hypotenuse, so we're looking to label our sides using the letters A, B, and C. So we've got A, B, and C. So the important thing we need to know about this is that our hypotenuse is always using the letter C. So C is this one here, and the other two are interchangeable, it doesn't matter, they're A and B. So from there, we've labelled our sides, we then substitute that into our formula. So step 2, sub into formula. The formula is the one that we've given just above here. So this one here, that's the formula we use to find the hypotenuse. And if we're substituting that in, we then put our values of A, B, and C in there. So if we go back, we've got A, which is 4, so we would write 4 squared plus B squared, which is 3, equals to C squared. Now you can put that straight into your calculator, you get an answer of 25 on this side, and that's equal to C squared. But we're actually after C in this triangle, not C squared, so we need to undo that squared, and the opposite of squared is squared root. So if C squared is 25, and I want C by itself, I need the square root of 25, therefore C is equal to 5 meters. So the main parts you need to really write is one line of working, so either this line or this line, and then obviously your final answer. So step 1, label the sides. Step 2, substitute it into your formula. And then I guess step 3 would just be to solve. Okay, let's do another example together where we're trying to find the hypotenuse. Alright, so if we have a right angled triangle, and I've got 10.4 meters on this side, and 7.2 meters on this side, and this is my unknown. So again, going through my steps, let's see what we need to do. Alright, so step 1, we've labelled our sides. So C is your hypotenuse, A and B don't matter as long as they're the shorter sides. So step 1 we've done. Step 2 is putting it into our formula. So 7.2 squared plus 10.4 squared equals to y squared, because that's what we're trying to find in this case. We can put all of this into our calculator and get an answer, or straight away we can write that y squared is whatever that gives us in our calculator, which in this case is 160. Or the next step straight away, we can just go to this to solve for y. So we know therefore that y is equal to 12.65 meters. Okay, the next two examples are going to look at finding a shorter side. So if we're given a triangle where we actually know the hypotenuse now, so we've got this triangle here, and this is 24 meters, so we're given the hypotenuse, this is 12 meters, and we're solving for x. So now working backwards, if we rearrange Pythagoras' theorem, you can use either one of these two formulas. So these ones here are to find the shorter sides. So it's important when they're all mixed up, we know which formula to find. Otherwise, we will get our answer incorrect. So again, we follow the exact same steps. So we're labeling our sides. So number 1, that's still our hypotenuse, so that's C. A and B don't matter at all. So we've done that. Step 2, when we put it into our formula, we now need to make sure we're using the correct formula. So we know we're finding a shorter side, so we need to be using one of these. I'm actually trying to find A, so I would go with this. Again, A and B are interchangeable, so it doesn't matter. I'd write 24 squared, take 12 squared equals x squared. Putting that straight into my calculator, or to reduce margin of error with rounding decimals, I'd probably put this all in one step. And then you would get your answer straight away, so therefore x is equal to 20.78 meters. So trying to reduce margin of error is really important as you work through with decimal numbers. So instead of actually writing this answer here, or as we see with the next example, I would just go straight to this step, show you're working out, and get your answer. Because the more you round, you're actually going to get further and further away from the answer. So we've done step 1, step 2, and step 3. We've solved. So we always write our answer, and we must include units and round correctly. All right, our last example, we've got a right angled triangle again, 12.78 centimeters, and we've got 1.4 centimeters. All right, going through our steps. We've got step 1, we're labeling our sides. If this is what we're trying to find over here, that's our hypotenuse. Let's call this A, let's call this B. Done. Step 2, we need to put it in the correct formula. We're finding a shorter side, so we would do the subtraction one. So we're using C squared take A squared equals B squared. So substituting, we'll have 12.78 squared take 1.4 squared equals to B squared. So that line is actually really important because it shows you know what formula you're trying to find. Then straight away, B is going to equal the square root of that answer because we don't want B squared, we just want B. We want the side length. So the square root of that line that's just above, and you'll get an answer of, to 2 decimal places, 12.70 centimeters.